Hey guys, welcome back to the channel. Something a little different here today. I need to make a triangular brooch for a Rolex 1030 hairspring stud. The stud that I had to get a new balance complete, and the stud that is on the balance wheel and matched to the balance wheel is about half a tenth too large for the current triangular hole in the stud for the balance cock. So I'm going to make a brooch here to kind of press that out. I don't have any files that are, this whole thing is half a millimeter in length here, and I don't have any files that are that fine or small, and I could try to use, a very thin strip of sandpaper, but I don't think that's the way to do it. So we're going to be making a rotary brooch today out of some O1 tool steel. It doesn't have to be particularly a high-end steel because it's just cutting through plated brass, so it should cut through it pretty easily. But I'm going to show you the process of how to make a triangular brooch. All right, so I've already hardened and tempered the steel that we're going to be using. I switched to a smaller diameter just because I didn't have a good size collet block for the one that I was using, or collet holder rather. I have the piece dialed into the spin fixture here, so it's running true within about 10 microns or so, so it's doing pretty good. And then I have the table indicated in, or I guess the spin fixture indicated in against the table, and I know the table's running true, and I have this it's about a quarter, or about 2.5 microns out, so I think we're going to be pretty good. This doesn't have to be super ultra precise, so I gotta get the wheel switched out now, and then we'll get to grinding. All right, I might have to edit the audio over this, but the first thing I'm going to do here is flatten the end of this piece, so that way we have a nice starting surface here. That looks good, nice and flat. So the next thing I'm going to do here is start roughing out the triangular shape. The angle of the triangle that we are making has, it's a 60 degrees. It's an equilateral triangle, so each one of the corners is 60 degrees. So I need to spin the indexer 120 degrees each time I rotate it through here, and then that'll give us our triangular shape. And I'll just start roughing it out, and I'll start miking it once we get a little bit closer, because remember, this thing's only a half millimeter from flat to point, so we're gonna have to just kind of ease our way into it. And also, you can see I have the stock sticking out, maybe about 8 millimeters. We want as little deflection as possible. So, and this is a roughing wheel. It's about 46 grit, so it won't heat the part up too much, but we'll get going here. I just mic'd it, and we're at 1.59 millimeters. And this is kind of what we look like right now. So we got to get down to 0.5, and I'm measuring across a flat and a point. I built this up in CAD. That way I know exactly what my dimensions are based on what the measurement on the flat and the point was and the included angles. So I got a little ways to go here, but that's what we're looking like. All right, well, I pushed the limits a little bit too much on this tool steel, and the triangular bit broke, so we're gonna make one out of carbide. All right, I got the carbide mounted in there, and I got the diamond wheel here remounted, so we're gonna try to give this another shot here. And again, the first thing I'm gonna do here is take a skin pass off the front of it, and so we have a nice clean square face. We got a nice clean face. I gotta get set up for the indexing cut. All right, and there we go. The triangular shaped brooch. You can see there's just a slight amount of taper going back. I just put a about a 3/10 shim in the back of that punch grinder, and the indexer, just to tilt it forward just a little bit. So there's just a little bit of taper there. Probably hard to see, and it's kind of hard to see the triangular shape of this thing because it's so dang small. But you know, here's our dimensions here. I just measured a flat to a point, and we're at 0.51. So I think I'm going to go with that. You know, 100 microns over is going to be all right. You know, it's not going to be a precision fit. You know, it's the collet or the hairspring pin. So it's not a perfect fit anyway because there's a screw holding it in. So there's our part that we made, and I just kind of wanted to show you guys how you can do that with a tool and cutter grinder.